Good morning, my name is Keaton Muller, and today I will be discussing the Tan-Chord Theorem, which states that the angle formed between a chord and a tangent line to a circle is equal to the inscribed angle on the other side of the chord. Here, for example, DBC or B is equal to BED or E. Let's inscribe that on our diagram with X. The same is also true for tangents coming from the other side, which means that EBA or B would also equal to EDB or D. We'll inscribe that on our diagram in red with Y. It is, however, important to note that Y does not necessarily equal X. The way in which one would structure these conclusions would be BDE is going to equal to ABE due to the Tan-Chord theorem, which you can just put Tan-Chord in brackets. We can also state that BED is going to equal to CBD due to the same reason, Tan-Chord theorem. Now that we have the basics covered, let's get on to the fun part, the proof. Let's take our original diagram and start off with our proof by constructing two radii, one of those being OD and the other being BO. We'll do so using a dotted line to differentiate them from the rest of our lines due to the fact that they are constructed. There we go. The next important step is finding an angle opposite to the angle formed between the tangent and chord. The most appropriate here would be E, which we'll let equal X. Next, we will be able to conclude that angle BOD is equal to 2X, due to another of the theorems we are learning today. Angle at center is equal to 2 times angle at circumference. We'll write that as follows. BOD is equal to 2x, and in brackets we'll put angle at center is equal to 2x angle at circum. You will now recognize triangle BOD taking shape. The immediate thoughts coming to your mind should be that this is an isosceles triangle. Therefore, OD is equal to BO, which we can conclude due to the fact that these two lines are radii that we constructed. The next thing we will be able to conclude comes from these two radii, which are equal in length. These two radii have formed this triangle BOD, and we can henceforth determine two things. First, that the interior angles together added up will equal 180 degrees, and also that angle ODB and OBD are equal to one another. Let's put down that first statement. 180 degrees minus 2x, which is BOD, is equal to OBD plus ODB. The reason we'll give for this is interior angles of a triangle are equal to 180. Now, let's look at those two. We know that we've concluded that these two are equal, but we need to put that down in our reasoning so that the examiner knows that we've concluded this. So let's put it down. OBD is equal to ODB for the reason which is simply isosceles triangle. This isosceles triangle has been formed by the radii. Now that we've proved this, we can rewrite our previous statement as 180 minus 2x is equal to 2 times ODB. Therefore, using some basic simplification, we know that ODB is going to equal to 90 minus x. Therefore, OBD is also equal to 90 minus x, due to the fact that we've proved that OBD is equal to ODB. It is now time to inscribe this proven information onto our diagram to make everything easier for us. Let's write this down. Angle OBD is 90 minus x, and angle ODB is also 90 minus x. This next conclusion also comes from a theorem we've learned today. We can state that OBC is equal to 90 degrees due to the fact that the radius is perpendicular to the tangent. Therefore, we can also conclude that angle DBC equals x due to the fact that angle OBC minus angle OBD is equal to angle DBC. Therefore, angle DBC is equal to angle BED, which you might recognize as the Tan-Chord Theorem. We have henceforth proven the Tan-Chord Theorem. Here is the proof in full. Now that we understand the theorems, let's look at an example to heighten our knowledge. Let's break this down piece by piece. EBO is equal to x. Label that on our diagram. Next, what we know is that OFB is equal to 105. Again, let's label that on our diagram. Next, FO is parallel to BD. Again, put it on our diagram. Label everything. This will help us a lot as we attempt to solve this problem. Now, we can see that this is a triangle, which means that the interior angles of this triangle are going to equal 180. So we can write that as FOB is equal to 180 minus 105 minus x. When we solve for this, we're going to see that our FOB is going to equal 75 minus x. Now let's put in our reason for that. Our reason is because interior angles of a triangle equal 180. Next, we'll have a look at our parallel lines. You may notice the end of a pair of alternating angles. And if you do, you'll realize that FOB is equal to OBD due to these alternating angles. Our reason, it's alternating angles due to the fact that FO is parallel to BD, which is given in the question. We can now label both of these on our diagram as 75 minus x. Our next conclusion comes directly from our question again. Our question states that AC is a tangent to circle center O at B. Therefore, OBC is equal to 90 degrees due to the fact that the radius is perpendicular to the tangent. Let's now label this entire angle as 90, as we've concluded that it is. Therefore, DBC is equal to 90 minus 75 minus x. So therefore, DBC is going to equal 15 minus x. Let's label that on our diagram too. You may notice that this angle is pretty special. It is the angle subtended between the chord and the tangent, and therefore applies to the Tan-Chord theorem. From this, we can determine that DBC is in fact equal to BED, due to the good old trusty Tan-Chord theorem that we've learned so much about. Let's label that on our diagram. You may notice that we have an angle on the circumference and an angle at the center. You may realize that we have a theorem for that. We can conclude with this theorem that BOD is equal to 2 times BED. And this theorem is that the angle at the center is in fact equal to 2 times the angle at the circumference. So now we can finally solve for what BOD is and finish the question. BOD in terms of x is in fact 30 minus 2x. Thank you so much. I hope I've been able to teach you at least a little. My name is Keaton T. Muller, and this broadcast has commenced.